Nate Butterworth. Good to see some of you again, and good to see some of you for the first time. And today, the goals is to basically introduce you to some Python concepts. So if you've never used it before, I think this will sort of get you started, get you the first building blocks. And with the state of how good large language models are at producing code and content, vibe coding is becoming very it's simple to do. And so if you just have a little bit of a foundation, you can really sort of direct it and understand what it's doing, I think. So hopefully we'll get you there. And so, yeah, we'll introduce some basic libraries. I'll talk about what all these words mean. If I use any in terms or anything you don't know, again, just ask. And we'll do a little bit of EDA, exploratory data analysis, as a little bit of a bonus as we go along. And we'll hopefully make our first calls to some large language models, both locally and in the cloud. So to get started, we're going to go and operate in Google Colab. Oops, so actually just wanted a new window. Let me go back. So Google Colab is, if you've never used this before, it's basically like an online Python environment. So I've gone there. I'm already logged in with my Gmail account, and I'm just going to click New Notebook for myself, and this should bring up what's called a Python notebook. And so Google has a specific, I guess, flavor or brand of these notebooks. You'll find Python in a lot of places. The traditional place is sort of like on the command line, and it can run what are called scripts and can be full applications. But one way that researchers and scientists use these notebooks that are a nice way to get sort of instant back and forth feedback that we'll see. Okay, and I'll show you sort of around this as we go. But at the moment, it's sitting there saying start coding, and I can start typing away in the prompt. So I'm just going to clean up my screen. I'll do that in a second, actually. Okay, so hopefully everyone is there. That has a notebook sitting in front of them, ready to go, because we're going to start writing things in here. I'm going to increase my font size a little bit so everyone can see how big, maybe that big. Hopefully that's big enough. Let me know if you can't see it, and I can zoom in a bit more. Now, this is the Python interpreter here, and it's waiting for me to do something. It does sort of maths and computations under the hood. So you can do things like, 1 plus 1. Oh, here we go. Here we can type 1 plus 1. And then to run this cell, I can click that play button there. I can also click, I think there's a run button, or there's run all, so I can run that. And I can also press Shift and Enter, which will execute it. And you'll see for the first time up here, it's just saying connecting. So it's connecting to some cloud resources, and it can give you a couple of cloud resources for free. So the first time you run a cell, it connects you to a virtual machine, which gives you some sort of compute. And in this case, it has now solved that equation, 1 plus 1 equals 2. Fantastic. Let me know if you'll fall behind at any point. Okay, great. So that's the foundation. Now we want to now capture some information as we move along and store it in the computer, and then resurface that information as we go and do experiments and do computations with it. So we can set something called a variable. And in the notes there, let's go back to the notes so we can see where we're at. In the notes there, I've got a few demos here explaining what these variables are, what the concept of a variable is, and it comes in several flavors, as we'll see. And just to sort of so you understand, we have I've got 3 kind of demos there. The first one should be kind of in its simplest form, and then the second one gets sort of a bit more complicated, maybe more in depth, and the third one is sort of more in depth again. But they all sort of say the same thing, just in different ways. But as you explore, you can see a few different examples. Okay, so I'm going to create a new variable called site underscore name, and I'm going to say equals heron 1. And I've just created my first what's called a string variable. And so what this does, it assigns this string text here to this variable name called site name. So we use the equal sign to assign a variable some sort of value. And now I can print this out by, in a notebook, I can just write site name and I can execute that and it should come back heron1. I can also do print site name and that will also give me heron1. So there's different use cases for sort of doing both of those, as we will see. And there's lots of different types of variables. So that's called a string variable. We can have a like an ID variable. So that can be that's called an integer. So far, I've just done one line at a time in a cell, but I can also just do multiple lines. So I can do an integer there. I can set a float here, pH equals 8.1. I can set something called a Boolean variable or a bool. And that's either true or false. Make sure I spell it right. So there we go, alert equals false. And so I can set those, and now they're in the memory of my Python interpreter. And so I can recall them at any time I want. So I can, get out the SID. There we go, 1. I can overwrite that, get out the alert. And there we go, it's printing false. So that's fantastic. We can do things, if I want to print this out, I can say, I can just write some text that the site name is, and then this print function takes, there we go, the AI is giving me some suggestions. So the print name, the site name is, and then if I put a comma and then write site underscore name, and then execute that, it will say the site name is heron1. Now, there's a few ways to kind of like print things and make them appear nicely. The other option is to do these things called F strings. And I'm just teaching you what these are now because we're going to see them a lot as we go through. So here I can say the ID is, and then I can put a colon, and then I use the special curly braces here, and I put SID and close the curly braces, close that, and execute that. And we can see that it sort of like stitches those things together. So that's a different way instead of using the comma syntax there. And similarly, I can also do print another F string. So I put an F before the start of the string and say the pH is, and then I put a curly braces, pH, and then you can do colon, and you can like format the string as well. So we'll see this a little bit too. I can say, let's say 5. So 0.5 F. So this is a language within itself, and I won't dwell too much on it. But basically, you can adjust the significant figures, and you can manipulate sort of like how the variable will appear once it's printed. So it's a handy little feature to know straight off the bat. And then there's also another command we can use called type, SID, and we can see that the type of the SID is an int. And if I replace that with alert, that one's a bool. And I'll just do this like I've got it in the notes. If I go type SID and run both, you'll see this one didn't execute, but this one did. And that's because of how the Python notebook sort of operates, in that it only executes it only will display the last line unless there's a print statement there. So if I do print type SID, then we'll see that it's then it actually does print the int, and it sort of wraps it in this sort of more informative thing as well. It tells us it's a class of type integer. Okay, good stuff. Everyone with me? So let's keep moving. Let's build. So that's the real foundations of Python, and the concept of these objects, which are variables in this case, and these variables hold certain types of information. And so these words, object, variable, type, you'll find them all across computer science, whether you're doing C# or Python or C or Rust or something. And they might differ slightly, but if you can read one language, you can at least understand other languages too. Okay, so the next one, we're going to look at these basic operations. So we've already seen plus, but you can do basically any sort of mathematical operation in your notebook. So let's just do a couple of examples. So if I do the start temperature equals 28.0, so that becomes a float, and the new temperature equals 29.5, then we can do things like a new variable, let's call it anomaly, equals new temp minus start temp, and I can execute that. And now this would have been assigned this this operation called which should hopefully equal 1.5. Let's just check that anomaly. And look at that, 1.5. Cool. So we can do more with that. Obviously, we can create another thing called bleach threshold, or bleach thresh equals 1, and we can say is at risk equals anomaly greater than bleach underscore thresh. And so this means it will check, is the anomaly greater than 1? Or so is 1.5 greater than 1? And if that is true, we can say print. We can print is at risk. Oh, okay, so fantastic. Our first error. These will come frequently, and it's very important to know how to sort of read an error. You can see here it says the trick to reading an error is that usually at the very end it tells you what's going on, and then there's a lot of scary stuff above that. So it says name error, name is at risk is not defined. So that means this thing that I've printed isn't defined. And if I work backwards, I can see that up here I've actually made a typo. So 90% of all errors are typos usually. So I just have to change that, and then hopefully that should work. There we go. So this got created, and it was calculated to be true. So there we go. And all right. So, and yeah, there's a bunch of other operators. So we can do greater than, less than, or equal to. You can check if something is equal to the other thing. You can say and or not, or do all these logical operations. And so we'll see a few more of those as we move forward. All right, now the next idea or thing we're going to talk about is an object called a list. So, or more generally, something called a data structure. So data structures are basically a way to store data in Python. And one that I think Python does really well is this concept of a list. You might think of like an array as well is a type of mathematical data structure. And there's we'll come across some other ones as well, like tuples and dictionaries and classes. But yeah, the list I think is a real foundational Python one. And what that looks like, just following the notes, if I say something like temp readings equals square bracket, and then I can put anything I like within these square brackets. So I can do some numbers, so 12, 13, 15, 22, so on. I'm trying to stay consistent, like with my spacing and everything. It's not too important, like if you have spaces or not. Spacing in Python is sometimes important, as we'll hopefully see. But as a rule of thumb, you should be consistent, and I think it's the style guide suggests having sort of spaces between an assignment like equals and spaces between list items. But yeah, it will work. It might just not look as neatly formatted. So keep that in mind. Anyway, so there's my list. I now have this thing called temp readings. Fantastic, 12, 13, 15, 22. Oops, I accidentally just clicked the code button. I didn't want that, so I'm going to remove that. And we can, I just printed it out by typing out the variable, but you can also, you can get to a single item, print temp readings. You can get to a single item in the list by using what's called an index. So if I say print temp reading 0, it will print the first one. So Python counts from 0. And I think most programming languages do. There's definitely some major exceptions. Like MATLAB, for instance, counts from 1. So that can be a bit confusing. But that is the 0th index. And then you can guess what the first index is, the second index, the third. And do we know what the 4th index is going to be? It's going to be an error. So it says index error. List index is out of range. But there's some tricks. If you don't know how big your list is, you can do something like -1. And you can get a little answer there. Cool. So that gives us the last value in the list. You can go -2 and so on. Now, you can also manipulate these lists. You can add items to them. So if we do temp underscore readings, so I'll start a new thing, temp readings dot append, and I say 29, and then I look at temp readings again. We'll see, look at that, I've got a new one in there. So this is called a method, and it's a special type of function, and we'll talk about functions in a second. It's a special type of function that belongs to these list objects. And so every object, so every type, data type, I guess, or every object type has certain functions or methods that you can perform on that. So you can imagine, doing like string operations, like manipulating how strings work, like concatenation, joining strings together. It doesn't make sense for things like integers. You don't join two numbers together, or usually. And lists, it doesn't make sense to append to an integer, but it makes sense to append to a list. So this method exists. And yeah, we'll see a lot more of that as well. We'll see more things. In fact, right now we can do temp readings dot remove, and if we pick one of our numbers, so I can pick maybe 22, and it will remove the first instance of 22 occurring, which was that index there, 0, 1, 2, 3. So if I now do temp readings, we'll see, oops, I just made another typo there, so name error. I did a capital letter, so I just have to go back and fix that. There we go. So temp readings 12, 13, 15, 29. Fantastic. We can do something like len, which is a little built-in Python function, which is the length of something, and it will give me now a length of 4. And if we go back up, we can see this temp reading still shows 12, 13, 15, 22, 29. So the notebooks work by they run sequentially, but they don't have to. So if I went back up and ran, I'll rerun this cell, then I'll rerun this one, it will get rid of that 22. If I rerun 29, I can run it a few times, and then we read it, we'll see that it's added it more and more. So just keep that in mind, that before Python learns about something, it doesn't know it exists until it's been executed, and then it's in its memory, and you can go back and forth within the notebook. In a normal Python script, you can't do that, but in a notebook, you can sort of jump around. And so we'll talk about this idea of like scope and variable scope, and where things exist, where Python knows they are, and whether it's been overwritten first, or whether it's the first time it's seeing it. So they're all paradigms to keep in mind. Okay, and I think the last sort of example I've got there, temp readings, you can do things called list slicing, where you go 0 to 2, and that will give me the that will 0 to 2 inclusive of 0, but not inclusive of 2. So 0, 0, and 1. Okay. Someone asked a question about how to do a reset in Python. You can go up here and go runtime, and you can go restart session. And if I do that, you'll see that it restarts. Hamid, if you've got a question, feel free to ask, or you can drop it in the chat. Probably the easiest, but you can also ask. Okay, and so that's restarted my session. Now, if I go temp readings, it'll say this does not exist, and I have to go back and redefine when I first define it up here. So if I redefine that, then these things will work again. Yeah, so that runtime and restart session is a good sort of cleansing task. Hamid, yes. You want to unmute yourself or just post your question in the chat? Hamid? Hassan? Hamid Hassan? Good. Okay.
Hello, sir.
Yes, go ahead.
Good morning, sir. Sir,
What
actually,
is
I'm
it?
not able to understand these things. I don't have a coding background. I'm a mechanical engineer, so it becomes very difficult to understand these things. I think
Okay.
there was any basic course from where we can get the things, actually how it works, what things we must remember. That will help quite.
Yep, absolutely. So at the end of the notebook is all the way down here. Basically a whole bunch of other tutorials, classes, recommendations for further learning and everything. So yeah, if you fall behind and just want to watch, like, this is probably a good intro, but there's a lot more as well out there. So I can stick that straight in the
Sir,
chat.
is there any beginner course available?
Oh, sorry, what was that?
Beginner course.
This, I guess, would call a big beginner course, but yeah, these ones are also beginner courses down here.
Okay, so thank you.
So yeah, at the start of those, they are beginner courses. But I'd recommend, yeah, just listening and watching, because all these things will be repeated in a sort of beginner course, maybe in a way you can better understand.
Thank you, sir.
Good stuff. Okay, so where are we? We've had a look at lists. Okay, another great concept is these conditional statements. So this is the common conditional statements are if and else. So I'll just go through the examples there. Basically, this is logic to say, you know, if something is true, then do something. Otherwise, do something else, or otherwise do something else. And yeah, let's see that out in action. So if I define something like a temp anomaly equals 1.2, and then I say if temp anomaly is greater than or equal to 1.5, I want to say print bleaching risk, coral bleaching risk. And the example is about coral bleaching. And now if I execute that in the way it is, nothing happened. So, but if I set this to 1.6, then it will print. So if I 1.2, nothing happens. 1.5, bleaching risk. 1.4, no, nothing happens. So anything greater than or equal to 1.5, that will be executed. I'll put it back to 1.2, and you can put like other conditions there. So I can say else, and yeah, otherwise print no risk. oops, no risk, close my things, and we'll print no risk. So just talking about the syntax here. So I set this Python keyword if, then I type the variable, and then I put the condition there, and then some condition that gets evaluated to true or false, and then I put a colon. So that's important. And then on the next line, it's very important. I have to tab in and have a bit of white space there. So I think a tab or a few spaces will work, but then you have to be consistent and keep things at sort of the same indentation level. So Python is really strict with that, and it makes it have good readable code. So if you go to something like C++, it doesn't enforce white space. You can just write everything on the one line if you want. You can run an entire program on one single line, or JavaScript or something. They do have semicolons. So at the end of every single line, you need to have like a special function to say, or a special item to say, this is the end of that last argument, move on to the next one. But yeah, Python uses white space to tell the computer when and where to do things. You can also do if. In the middle, you can do L if. And we can set other conditions there. So temp anomaly greater than or equal to 1.0. We can say print moderate risk. Okay, so I run that, and I'll see that this one was evaluated. It wasn't true, so I went to the next one, and it was true, and so it printed, and then it ends the little conditional clauses we have there. Okay, all good. So the next sort of idea is this idea of loops. Again, very powerful. Like all these things so far, they're in every single programming language that you could use. And the two main ones that you'll come across are probably for loops and while loops. So one is for all these objects that I have, I want you to do something on all those objects. And the other one is while. So while this is true, keep doing this. So they're the basic ideas behind them in plain English, I guess. And we can see what they look like in action. So if we start with a list, so I can do ref names equals, oh yeah, and just on variables, I haven't mentioned it, but you can use sort of underscores to assign a variable. You can't, wait, let me just define this. You can't use like a dash. So it says syntax error cannot assign to expression here. I think it's basically, yeah, underscores. You can't use like special characters. You can't use, you can't start with a number, but you can end with a number. So, or you can have numbers in between. So, yeah, there's some ideas in, or some rules around like what you can call your variables, but you should keep them, yeah, something reasonable, lowercase, uppercase, and underscores. All right, so I'm going to make a list with words Heron Island, colon, Lizard Island, Osprey Reef, and Ribbon Reef. Okay, and now I'm going to do a loop. So for reef underscore name in reef underscore names. So that's the syntax. We can say for some, sorry, let me close this. So for some new variable name, I've called it reef name. We can call it anything here. So in reef names, so for something in these items here, I want you to print my reef name. And if I run that, it should run through 4 times, 1, 2, 3, 4, and print out each one. Now, I could have called this something like R. I can call it anything I like, but I can't call this anything I like. So, because that one's looking for something that exists already. Okay, so this R only exists within this this for loop. but it is good to have something meaningful, I guess, for reef in reef names or something. Okay, so that's a for loop. You can do things. You can use like ranges. So but the concept of this range item. You can set numbers like from 0 to 10, let's say, and it creates this thing called a range operator. And I can say for, let's say, day in range 0 to 10, I can say print day, and that should print numbers 1 to 10. So there's lots of little shortcuts as well. You could just write out those numbers as a list, but there's sort of other ways that you can use these for loops beyond just iterating over a list. That's the point of that. Okay, and so a while loop, let's do a while loop as well. So if I say, let's set up some variables first, current coral equals 20, target coral equals 25, year equals 0, and then I'm going to say while current coral is less than target coral. So while this number, current coral, which is 20, is less than 25, so it's currently true, I want you to do something. I'm going to say year. I want you to add a year. So I'm going to say year equals year plus 1. And in the notes there, it's actually written as year plus equals 1. So it's like that's a little Python shortcut. You can have one or the other. They mean the same thing. Okay. And I'm also going to say current coral. We'll do plus equals for this one, 1.5. And let's just go print. Print, let's say f string year, and coral, current underscore coral. Okay, so I'll just run that. And so it's gone through year 1, it's incremented year by 1 and coral by 1.5, year 2, year 3, year 4, and so it keeps increasing both of these. In the 4th year, coral went to 26, so the current coral was 26, and the target coral was 25 still, so that didn't change. So then this evaluated to be false, and so that way the while loop ended. And then in the notes there is also the if statement, so you can put like an emergency stop in there. So if you wanted to simulate something and say like, I only want to run this for 10 years, so you can keep counting the years and then break that. You can use this break command to sort of exit the loop in a different way. So there's kind of multiple ways that you can escape from a while loop. Okay. All right. So that's loops. All right. We're getting into some good stuff now. That's like all the basics, which is fantastic. In 30 minutes, might be very fast for some people. Hopefully, okay for some others. You don't need to remember all this. Obviously, we'll keep repeating all these fundamentals as we get to the AI section and redo them. So we'll focus on that in the second hour of today. Okay, but we're going to introduce this idea of a function. So instead of having to write code again and again and again, you can think of a function as like a reusable piece of code. And so if you want to write a piece of code that does something and then reuse it again, you can use a function. So in this example here, we have a very simple function that just converts Celsius to Fahrenheit. And the syntax of the function is that you define a function here, C2F, and you will pass it some number in Celsius. And I haven't mentioned yet, actually, these with a hash here, these are comments. This is for a human reading code. basically the interpreter Python just ignores anything any line that starts with a hash sign. So hopefully people kind of figure that out. And also there's a way to put comments in a different way. You can use three quotation marks, and that will produce a multi-line comment. And you'll see this a lot at the top of functions to describe what they do, again, for humans, and also as we move into the present operating world. AI models also use these headers to understand like what the function does, and can help guide like AI models to how to use them. So this one says it converts temperature from Celsius to Fahrenheit. The arguments, args, is Celsius, and it says you have to pass a float or an integer, and this represents a temperature in Celsius, and then it's going to return, once it's finished, a float value, and that float will be temperature in Fahrenheit. Okay, and then the calculation is there. It's just the typical calculation for how to calculate Fahrenheit. So it equals Celsius times 9 divided by 5, all of that plus 32, and then it returns the Fahrenheit value. So let's create this function, and then we'll see how to run it. Okay, so, and the way to do it, you use the word def. It's a Python keyword. I think it must mean define. C to F, you can call it whatever you like. But CTF works, and you can call this variable whatever you like as well. And this variable will only exist within the function itself. So I've just called it Celsius. You could call it temperature, or temperature underscore Celsius or something. We don't have to put the header in. That's optional, so I'll leave it out. Now I'll write the word Fahrenheit and spell it correctly. Fahrenheit equals Celsius times 9 divided by 5 Celsius plus 32. And I think that'll work. Yeah, so that will be executed first, and then add 32. It won't. If you put brackets around here, if you ever remembers BODMAS or PEMDAS or something, that will be very different to this. Sometimes it's good just to be clear in your programming to make it clear, but I think that will be analogous to that. Anyway, I'll leave it in. You can test it. Okay, and then you don't need a return function. Maybe your function just prints something, or maybe it calls another function or something. So Fahrenheit. There you go. Spell it. Very good. Fahrenheit. So this one doesn't have a print function. But I'll just run it here as an example. So what do we call it? C underscore 2F, and I can just pass it a number. So that's how once you've defined it, you can then call it by giving it its name and passing it sort of the value that it requires. And that should just convert it. There we go, our very first function. But if I want to do something more than that, I can put the return statement in. Fahrenheit, and now I can assign this. So I can say temp F equals, and now I can do what I want with it. I can go print, temp F. So I can print it twice. There we go. So that's a function. And what you'll find when you write enough awesome, amazing functions, you can bundle them all together in a package, what's called a Python package, and then you can give it to the world and share it with people. And we'll discover that, I think, right now. Okay, so was there a question, someone?
I was going to say yay.
Fantastic. I love the enthusiasm. Good stuff. BIMDAS. And do any other countries use besides Fahrenheit? I don't know the answer to that, but
damn Americans.
Okay. All right, their functions, yeah, I don't think there's anything else to talk about there. But we'll see a lot more function as we go along. Now, yeah, like I said, once you've written enough functions, you can package them all up into a beautiful module or and give it to the world. And so this is really where the power of Python is that there are millions of packages and developers and people around the world who are using Python and making things easier. You know, stepping away from ones and zeros and bytecode and everything, and just making it easier to work with. So you don't have to rewrite a Celsius to Fahrenheit function because it already exists. And one of the biggest packages is called NumPy, called numerical Python, and you'll see this come up a lot. It under the hood, it's actually written in, I think, like C and Fortran code. And so when you execute it, it's actually running like super fast. So some people used to say, you know, Python's slow compared to these languages. But a lot of the time, if you're using NumPy, then it's arguably the same. One thing you have to get good at as you learn programming and everything is reading documentation. So, you know, I definitely don't remember any of this, but you go to the documentation website, and if it's a well-maintained package, you can look up something. If you can find there we go. There's the documentation. You learn how to install it. You can normally find yeah, how it works. And so NumPy in particular is really good at doing matrix manipulation and arrays. And so that's what it does. Very fast, very optimized. So there's no point in you trying to like add two matrices in native Python because someone's probably optimized it and written it very well in some other language, some other package. Okay, but we will let's import it, and we can just explore like some of the little tools that are built into NumPy. Okay, and so to start, I should just mention also, whenever you want to install something, Colab by design, I'm just going to minimize this. Colab has lots of packages already pre-installed. If you install Python on your local machine, you might need to install extra packages. And most of the time, you might use something called PyPy. And so PyPy, yeah, there's 800,000 projects, 8 million releases. So if I look up NumPy, it'll tell you I install NumPy using this command pip install NumPy, and that sort of plugs it into your Python installation, and then from there you can start using it. And so yeah, PyPy is a package manager. It's a repository that's built for Python. There are other ones as well, but PyPy is definitely the sort of the biggest one. Another one you may have heard of is Anaconda or Conda, and I can't think of any others, but I'm sure there's more. Okay, so to start using those packages and functions that exist within NumPy, we need to tell Python to load them into its memory. So the way to do that is go import NumPy, and you can just do that and start using it. But often you'll see import NumPy as NP, because I guess Python developers are lazy and they want to write as few words as possible. So what that does is just makes NP a shortcut to NumPy. Okay, and then we're good to go. So firstly, I'll make an array here. So if I do temperatures in Python, so temps pi, and I'll just do 28.5, 28.7, following the notes here, 28.8, and 29.1. So that's a typical Python list. We're familiar with that. And if we want to convert it to NumPy, we can go temps np equals np.array, and then temps underscore pi. Cool. So now I have this thing called a NumPy array. And as I mentioned before, so if I compare that to temps underscore pi, you know, they look kind of similar. The values are the same. This thing has an array around it. If I do type on it, you can see that it's a NumPy ND array, an n-dimensional array, as opposed to type of temps pi. That's a list. They have different methods and functions that are associated with them. And so, yeah, some of them are things like, let's do np.mean temps np. And that gives me the average, the mean of those temperatures, which is probably much far. I think there are built-in Python mean functions. Actually, lots of different packages have like averages and everything. I can do the standard deviation as well. Temp equals np.std temps np, and I'll put one more line there. Temp. Cool. And so that's the standard deviation. What happens if we do mpy? Let's do that. Let's do the Python one. Will that work? Oh, it did work. So what this did, if you do the NumPy standard deviation, we use that function. So that's how you call it. You say NumPy that we imported before, and then we go dot, and then standard deviation. And that's often how you call a function that's within a package. And then we pass it this variable. And we can actually pass it the Python list directly. I don't think you used to be able to do that, but you can, which is great. That means we don't have to first turn it into an array. It sort of does that step for us. Okay, and yeah, we'll see some more packages sort of as we go along, but that's just to kind of give you an idea that yeah, you can go np.mean and you have access to all these things. Can I do? I think I can go help np. Will that give me documentation? I think there's built-in documentation. There we go. So there's built-in documentation if you type help, but it's probably easiest just to go straight to where it is. All right, that's printed out actually a lot of help. So I might just delete that cell because it's a bit too much. But yeah, it's all right there at your fingertips if you forget something or need something. Okay, so the next package which I can roll straight into is Pandas. So Pandas, this is sort of built on top of NumPy. So NumPy only deals with numerical data. Pandas deals with any type of data. You can put anything in what's called a Pandas data frame. You can think of a data frame almost like an Excel spreadsheet. You can put in numbers, you can put in text. I think you can put images, maybe you can put like functions in there. You can put all kinds of things. You put lists in there. You can put NumPy arrays inside a Pandas data frame. So you can have all these complex objects inside this data frame. And I find in research you use it a lot because you use this panel data a lot, and you want to do lots of sort of exploration with it. And so what we're going to do is just define a little Pandas data frame. I might actually just copy that because there's a bit to type out. So I'm just going to copy this data dict. And this is in fact another type of object. That's a Python object called a dictionary. And inside that is this thing called a ref ID. It's got the location, it's got the coral cover percentage. So there's strings, there's integers, there's also floats as well. And I'm going to convert that to a Pandas data frame, going like this, df_refs. Oh, sorry, I need to import it first. Actually, I'm just going to do this and pretend like I forgot to import it. So pd.data frame data_dict, and it'll say, oh, name PD is not defined. So that's the same error as when we made a typo. This time I forgot to import Pandas. So Python doesn't know what Pandas is yet. So I have to go import Pandas as PD. So yeah, again, the common shortcut for Pandas is PD, like NP. Now if I rerun that, it knows, oh, okay, I've actually attribute error module Pandas. So at least got me that far. So it says PD, Pandas, has no attribute called data frame. So there's no attribute for these pandas called data frame, and it's because I made a typo. It should be data frame. And if I run it again, I now have this thing called df refs. Look at that, and it's a nicely formatted data structure that we can you can easily digest as a human, which is nice. Okay, and then there's plenty of things that you can do with this. You can do refs.head. You can get like the first value from a data frame. You can df refs.info. So you can get, I think this is like a summary of the data frame. It tells you, all the column names. You might have thousands of columns, so it gives you all the names. It tells me how many real numbers are in there, I guess. So it says non-null. So null is a concept in Python. It's not zero, it's null. It's like not defined. But then also there's nan, which is not a number, which is another way that things are not defined, and they can be different in different circumstances. And it tells you the type as well. So this is an int, a 64-bit integer, an object, a float, 64, another object. So an object is kind of like a catch-all for strings and text. Okay. And we can do df refs.describe. Great. And it gives me a quick summary, a statistical summary of all the numerical objects in there. I can tell the shape of it. So if you do any coding at all, you'll see that getting the shape of objects and knowing what format they're in is used all the time. So in this case, it's 5 by 4. So it's 0, 1, 2, 3, 4, 5, oh, 5, 1, 2, 3, 4 for 4 columns and 5 rows. So it's 5 by 4. And you'll see that this one didn't have a parentheses. It just had no parentheses. I forget what the difference is there, but yeah, so sometimes you have a parentheses and it might take an input, and then other times you don't have any parentheses, but read the documentation. Okay, and we can also select things out of there. So just like we can select things out of a list, we can also say df refs, and you can say like, give me the location, which is the name of the column, or you could say location equals Heron Island, and will that do anything? So that's then said true, false, true, false, true, false, true. So it's turned those this into a true and false data structure, and I can sub-select values in there by doing df refs and then putting that all within square brackets, and it now just selects the 2 rows where the location is equal to Heron Island. So you can see how powerful this is, like in selecting and manipulating data just from like a few lines of code, and doing that rather than going and clicking buttons in Microsoft Excel. You might have millions of lines or something. Yeah, it's really powerful. And then if you're like, oh, actually, I don't want Heron Island, I want Heron Island plus this, and you want some like bespoke sort of formula, you can easily do that. Okay, so well done. I've written here. You've made it through the intro. You are now equipped with the basics, and so with these foundational building blocks, we can basically do anything, and it just kind of gets more. From here, we'll build onwards and upwards. So we're going to talk about large language models today. Now you have probably used a large language model by now, but hopefully we can bring it a bit closer to you, and you can sort of understand sort of what it is and how to sort of make it do exactly what you want, and you can be a bit more in control of it. In this context, AI, it used to mean a lot more than sort of a generative AI and large language models. It was sort of every kind of aspect of computer science that that encompassed different sort of statistics and machine learning. And machine learning was in fact a subfield of AI used to make predictions or decisions. And then, so large language models, they're a specific type of model, which is a deep learning model or a neural network. And modern large language models are based on the transformer architecture. And so they're basically trained on vast amounts of data, and they can do lots of different things, as we've probably most all experienced. And we'll spend some time with two today, Gemma and Gemini. So they're the two sort of main family of language models offered by Google, and we'll learn a little bit more about them. There's a bunch of things that you can do. I'd sort of love to hear what people are doing with large language models and AI in general. There's always new use cases that just astound me. So let's and as always, these can be biased, they can hallucinate and everything. So you tread carefully, I guess. Okay, so we today are going to pull some models. So we will peel back the mystery, and we'll see that a language model is basically it's just a data file. It's basically some matrices, a NumPy array almost, saved on your computer somewhere. And when you type in a request to it, it goes through that array and it turns it into text, and something comes out the other side. And you can download these models directly from a lot of different places. One of them is Kaggle. So the Kaggle platform is it's a lot of fun if you haven't used it before. If you're new to programming as well, it's a great place to sort of get started, especially if you're going into like machine learning and AI and everything. They host these competitions where you try and make predictions and work with data to I guess understand that data in rich and interesting ways, and the community is really strong and helpful. And I think I went in a competition, and the highest I've ever gone is about a 1,000th. So don't feel bad about where you rank, but where you participate. Anyway, so there's competitions, but you can also download data sets. So they have data sets there, and they also have models. And the models are super cool. You can get a huge variety. Let's have a number somewhere. It's probably thousands of large language models and AI models and vision models, and Perch is an audio model from different providers. So Google is one, but they also have have GPT models and Mistral and some other big names as well, DeepSeek, and so on. And so we'll use Kaggle today to download our models to our local machine. I say local, in this case, we'll be using Google Colab, but it would work the same if you're on your local machine too. And yeah, we're going to be using the Gemma family of models. So Gemma in particular is, they've just released Gemma 4, I think last month, which is always exciting when a new variety comes out. Usually it's a bit more performant and everything. We're going to use Gemma 3 today just because the variations that Gemma 4 has, Gemma 3 has a really small version that's easy to use on a CPU. So currently our Google Colabs are using a CPU only, no GPU. These bigger ones, they could work, but they might be much, they might be very slow and maybe too big, especially, these bigger ones. But I'll talk more about that. But anyway, Gemma is the open weight models provided by Google. So there's different varieties of openness in the model world. The Gemma models are open weights, meaning they give you the matrices that make the predictions, and that's it. They don't tell you what data it was trained on, and they don't give you the architecture that defined like the code basically that built the model, which is okay. So then there's other models which are completely open source. So they have the data sets that are trained on. They have the code that was that was used to build them, and they have the final weights that they've used. So some of these models, they might take like weeks to train on some huge cluster of thousands of GPUs or TPUs. So, just getting the weights is probably within reach for most people, but training the models is difficult if you don't have access to those machines. So anyway, we'll talk about Gemma a little bit more. And the other thing we're going to talk about is Keras. So there's lots of different options for interacting and interfacing with these models. Today, we are going to be using Keras. I like Keras because it is very high level, which means that it doesn't have many options. You can't tweak it to the nth degree, but it's good enough that we can get it to do what we want. So, and we'll see that it just takes a couple lines of code to interact with these. Whereas if we use some other frameworks, so frameworks include JAX, TensorFlow, PyTorch, which you may have heard of, or transformers, they usually take a few more lines of code, but you could also do a lot more with them. So Keras just tries to make it as simple as possible. Okay. All right, so that's a very brief intro. So let's import the libraries that we need. I believe they're already installed on Google Colab. If we need to, we can update them directly in Colab, so we can install new packages on our Colab instances. But I think we can just import both. So you can keep using the same notebook. You can keep using the same notebook if you like. I'll start a new one. Maybe I'll save my last one to show you how to do that. So let's call it GDG demo 1. Okay. And that is saved. And I'm just going to go new notebook in Drive, and I'll create a new one. I didn't show you how to how to save it last time, but it basically saves automatically. I just gave it a name. So this one, I'll call it GDG. Let's call it AI demo 2. Okay. I'm going to close this. I'm going to just, can I turn my AI off? Editor, AI assistance. Let me turn that off so it stops getting in my way. Okay, good. Generative AI features. Good. You can leave yours on if you like. And I'll click connect, and it'll connect me to a runtime. And I'm going to toggle the header visibility. I'll do that in a second. Actually, so I'll click connect, and just while it's connecting, you can click up here and go change runtime type. So by default, it gives you a CPU, but there's an option for a T4 GPU or a version 5 a T4 GPU or a version 5 TPU. You can also pick R or Julia if you have a different flavor or language you prefer. So they have other resources available. I think there's some time limits imposed on those, but we can make do with a CPU today. Okay, I'm just going to hide this as well, so I'll get a bit more screen real estate. Good. And we'll go back. So I'm going to import my 2 libraries, and then we're going to do something which I think is the hardest thing we do all day. I always say that. Okay, so import Keras _hub and import Kaggle hub. So this lets us connect to Keras and lets us connect to Kaggle. And I'll run them. Hopefully that'll work. I'm just going to print the versions. Actually, I probably don't need to do that. In the notes, they have the versions. I think the versions are okay. They do update Colabs from time to time, so they'll install newer and newer versions, and that can break things, especially in the AI space where things are evolving rapidly, where one function existed yesterday and it doesn't exist in a new version. So just keep that in mind. Okay, now what we need to do is we have to log into Kaggle. Now you can do this with your Google account. So if you're in Colab, then you should be good to go. But basically, click on the link there, kaggle.com settings API. So I'm not signed in at the moment. I'll just go sign in with Google, and I'll sign in with my GDG for Science account there. And okay, it's taking me to my API page. I'll just put that link in the chat. This is, as I said, this is the hardest, one of the hardest things we'll have to do. We'll have to do it again though. And now what we have to do is create like a password, I guess, that connects us securely to Kaggle, so they know we're not spamming their servers or anything like that. So if you've ever used something called an API, then this is an API. And so if you connect to any server in the world, there's different ways to connect to it. A lot of the time you use a username and password. Kaggle uses these API tokens, and it's fairly straightforward. We click generate new token. I'll give it a name, G2G demo, and I click generate. And it's printed up on my screen. Now, it's important that you never share this with anyone, so I'll delete this sort of straight away. You can treat it like a password, but I'll copy it to my clipboard. I'm going to go back to my notebook, and then I'm going to go Kaggle hub.login, and I run that, and it says, please put your API token in, and I'll paste it in there and click login. And good stuff. It says my credentials are all set. And so, yeah, if you accidentally leak your password or whatever, you can just delete it and make a new one. So, like I can expire that token. Very good. And but then it won't work anymore. So let me just quickly make a new one. Okay, good stuff. So that's a little tricky. If anyone, yeah, let me know if you need to do that again. I'll just run it again. Oh, it's asking if I'd like to save it. Log in. Good stuff. And I've been validated. Okay. So, okay, then the next thing we'll have to do is on Kaggle, you will have to go to, now I've already done this, Gemma 3, I'll send you a link. So you'll have to go to Gemma 3 and, yeah, Richard, yeah, you definitely could do that. There's quite a few ways to kind of set this path, like set the secure token. You can set it as a variable, you can set it as an environment variable. Yeah, there's lots of different automated ways. And I think in the notes, I link off to explain, yeah, how to do it in a different way. So yeah, there's lots of different ways to do it. Okay, so now you need to go to that page that I posted, Gemma 3, and here it says you've consented to the license for Gemma 3. So you just have to click on accept license. Not all models allow this, require this, but quite a few do. So I've already consented, but I can do it again, I guess. And it shows me that I've consented and just said like I will use this for good, not evil, or something like that. No, I think it said like you have to. I'm not quite sure exactly what the terms are, but you should read them definitely. Okay, so once you've accepted, otherwise you'll get a mistake in the you'll get an error that comes up. Okay, cool. So next part of the code, we're going to download the model. There's a bit to it. I'll type it out, or you can copy and paste it if you like. So Gemma, I'm going to create a new variable called Gemma. So it's just a variable like we've assigned before. This one is a Keras hub.models, and I'm specifically using this. So we have this like nested stack of functions basically, or methods that are buried in sort of different modules. So Gemma 3 causal lm dot from underscore preset, and I'm going to grab this model. Again, you can copy and paste. You can it's listed here. So again, I didn't just make this up. I copied it from somewhere originally, and it has the download like where this exists. Can I do that? I don't think you can. No. Okay. So it's this model here. It's got a specific name, Keras/Gemma3. So Keras/Gemma3 underscore 270. So I'll unpack what that means in a second. I'll just get it started. And so I need to do a quotation marks, Kaggle, colon, // and then I'll paste what I copied there, make sure the syntax is right, and I'll hit run, and that should hopefully start downloading. If you get an error saying like, you know, the model is not authenticated or something, you either have to authenticate here or accept the terms. Okay, so that'll take a second, and what we've just downloaded, it's not too big, it's half a gigabyte, 500 megs, is this version of the model. So we've chosen Gemma 3, but picking Gemma 3 is only part of the story. The other part is buried in the documentation here. So we have to now pick what flavor or variation of the model we want. We have to pick the framework we're using. So we're using Keras, but we could be using PyTorch, Transformers, Gemma C++, GJUF, all these different types that just put the model in a slightly different file format. That's all it really does. But then within that, we have to then pick the size, kind of the different type of model within that. And there's a couple, 24 here or something. And they come in all these different sizes, basically. So it says Gemma 3 and then underscore, and then it's got a number 1B. So 1B stands for 1 billion, 12B, 12 billion, 270M, 270 million. So that's the smallest one. So basically, the bigger that number usually is, the better the model is. Let's use the word better. And so that's what that means. And but basically, you need a bigger GPU or a bigger computer to run the bigger models. So for demo purposes, 270M, perfect for us. Okay, that's downloaded. I have this thing called Gemma. It's this weird type of variable called Gemma3 causal LM. And yeah, like you don't need to know what type it is or anything, but it's a Gemma 3 Keras model basically. And we're going to do stuff with it. So, and in fact, it's very, very simple. We go Gemma.generate. And we can say, what is coral bleaching? And we ask a question. And so while that's thinking, this is simply, we've downloaded this model. This is all local. So you could be doing this on your local machine. Over here in the side of the Google Colab is like the computer system of the Colab. So we can browse around the files that we have here. And this has just downloaded a couple of files to, notice it's in root, cache, Kaggle Hub, models, Keras, Gemma 3, Keras 270M, and then in 3. So it's in here. I just wanted to show you, there's nothing secretive or like, weird about this. All these are just files in a computer that is storing what are called the model weights. So that's a pretty big file. That's this giant matrix of numbers basically that describe what to do with the different tokens or the different words that you pass to it. And then it's got a couple of config files as well. And so that's it. So you can put that on a USB or whatever, or email it to a friend. But as long as you have those files, you can perform model queries any way you like. Okay, so I missed a little something from the notes there, which was to put in the max_length variable. So what we'll discover though, that's why it's taking a long time. Hopefully, if you put the max_length variable in, it will behave nicer. I think this will probably take a few minutes. Maybe I'll stop it actually. I'll stop it if it can. It's going to stop. Might not. Okay, let me try max length equals 50. So while it's doing that, yeah, right. Okay, so it's running. So the smaller the model as well, the harder they are to tame. They're designed for specific things. So the 270M model is designed for like going on like mobile devices and for performing specific functions. It's not designed like the large Geminis and ChatGPTs of the world to answer like every single query and read vast amounts of stuff and everything. It's designed to like be tailored to specific tasks. And so, as we'll see, it can be quite unruly with what can happen. All right, is that maybe I might in fact do this. Let's go runtime restart. Yours might be running. Now, I should point out, if we were, I'll have to get my key again. Did it work? Oh no. Okay, I think we're back in action. Okay, and this might break for me actually. That's okay. That's okay. I can figure it out. So settings. I'll have to generate a new token because I did not save that anywhere. So that's fine. Okay, log in, and is this going to work? Oops. I have noticed, I think it's a bug. Okay, so with this model in particular, if it already exists on my computer, then I get this I get the permission error saying like you don't have permission to download this again. But I've already got it, so I think I can just cheat a little bit, and I can actually just go and copy this path, and I can say just load it from here. So there we go. I think that's a bug. It should just download it and overwrite it, but in this case, it actually yeah, didn't do that. Okay, hopefully that figures it out, and I'll run this again. Generate. Okay, so that should take about a minute now that we're back in action. Good. So this is running remote on a CPU. CPU is definitely not designed for this kind of thing. If you can run it on a GPU, it'll be like substantially faster. And if you come to our sessions over the next few weeks, we'll hopefully get to see that. Cool, there we go. All right, so it says, what is coral bleaching? And then it gives me the answer back. It gives me /n/n, that means new line. Coral bleaching is a natural phenomenon caused when corals are blah, 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 and then it just truncates and stops. So that must be 50 what are called tokens. So a token is kind of like a word, or maybe a phrase, or a couple of words, or maybe half a word, depending on how the model provider has defined what a token is. But it's basically the way that that matrix of numbers interprets different text and different tokens. It says, oh yeah, this thing is a token. I've seen this token before, and I'm going to generate more of these. Okay, but yeah, the cool thing is we're running everything local, and you can ask it all kinds of questions. So I did also suggest in the notes to try this other model, which is the instruct model. So the instruct model, I just copied that one across. It's almost exactly the same as this line up here, except it's the instruct _270M. And the instruct model is probably closer to the models that you might be familiar with, in that it's trained on like question and answering, whereas the other ones, as I said, they're a bit more unruly. Okay, so I've re-downloaded this instruct model. I've clobbered, so that's a specific word. Clobber means I've overwritten this Gemma variable, and that's kind of to save on space and storage and memory. Otherwise, I might run into like out of memory in the Google Colab instance. So if I just overwrote it, I kind of released all that memory from the first model and replaced it with this one. I can ask the same question. It might behave fairly similarly for that particular question. But yeah, you'll see like sometimes it goes off the rails, especially the non-instruct model, I find. Okay, and now, so I had a task in there. It's very full on and complicated. I might just we can actually we can copy and paste it, I think, and I'll sort of talk through it. So it says, what is coral bleaching? Now, if I did ask a follow-up question, and I said, what causes it? it has no memory of my last question that I asked. So keep that in mind. Like all these things, when you go to Gemini.com or ChatGPT.com, there's a lot of Python or a lot of code pipes in the back that kind of make it a pleasant user experience. These naked models, these raw models, you have to sort of roll your own. You have to roll your own for everything, and so. When I say what is coral bleaching, it gives me an answer. And I say what causes it, you would think that it would know what coral. You're still talking about coral bleaching, but you haven't modified the weights at all. You haven't put anything in memory, and so this is like a brand new question to it, and it's just responded with like some nonsense. So in order to pass the right context to our question, so it knows the context of what causes it in this case coral bleaching, we need to sort of write a function that can do that. And so in the notes here, I've written this sort of function, which I think looks kind of complex from the outset, but if you look at it, it's everything we've covered today. So we define the function, we give it a bit of a story here in our in the header. We then set an empty string. We have a for loop there. So for turn in the history, so the history being our conversation, we're going to, this is a dictionary because we pass, here we go, we pass it a list of dictionaries. We're going to select the role variable from the dictionary or the content variable from the dictionary. And then we have an if statement. So if the role is the user, then we're going to write this as our prompt. And if the role is the model, then I'll write this as the prompt. And if it's anything else, then it's going to say, hey, there's an error. I don't know what you passed me. And I've specifically built this this weird string pattern here, start of turn, end of turn. And that's called a prompt template. So most models have like have a prompt template that they've been trained on. So in theory, they perform better when they are passed that prompt template. And if you build out your content in that structure, it should behave like how you expect it. Okay, so that's the function that we use to build up that prompt template. And what we have to do basically is pass it our question. We have to get the response of the model. We then pass it the question that we first asked and the response plus a new question. And that's actually what's happening when you're interfacing with an AI model on the web. You're just passing the whole conversation history back and forth. And yeah, there's sort of ways to make that more efficient. But as conversations get longer and longer, even with the best models, they start to go crazy because they forget what you were talking about at the start. They forget the context. Okay, so in this case, it's going to ask the first question, what is coral bleaching? And then the second question, what triggers it? And but instead of just asking them by themselves, it's actually going to run through and do them twice. It's going to pass it back and forth twice. So what is coral bleaching? It's now running the prompt, and then it will append the answer that it got back to it. So yeah, sorry that's I think it's fairly complicated, but you've learned all of this today, which we can unpack. Okay, so yeah, you can so the takeaways of this section that I sort of want to tell people about, you can work completely with local models, and Keras lets you easily interface. We literally did it in one line, keras.generate, and the model choice, that the one that you pick, the rule of thumb I think is pick the instruct model and pick the largest number that you can fit onto your machine. So that really depends on what you can run. So the Colab default instances have 2 CPUs and 12 gigabytes of RAM, which is really not much, and yet we can still run that model. But if you select a GPU or TPU instance, you can put sort of much big models on there. Okay, so yeah, that's finished. And you can see that chat template there, start of turn, user, what is coral bleaching? End of turn, start of turn, model. Coral bleaching is the process. And then it passes that entire thing before it asks the second question. So what triggers it? And then it sends everything, and then it gives us an actual model based in the context. So temperature changes, rising ocean acidification and pollution. Cool. So that's local models. Okay. We've got about 20 minutes to do one more fun thing, which is using the Gemini API. So there's a question from Pat. When running LLMs on your local machine, like your example, does the model weight file save or good question. Yeah, so when you download that, if it was your local machine, that would just be a file somewhere on your computer. You can tell Keras where to download it to, but the default in this case downloaded it there. You can also just download the model and then tell Keras where it is on your computer. So that's kind of what I did when I pasted it back in up here after I got that error. So I just pointed it to a folder on my computer. So yeah, you can definitely do that. And okay, so I mentioned that briefly. No, basically the answer is no. It won't update your model file. Your model file stays as is. But come along to next week's session where we'll learn all about fine-tuning LLMs, and we'll learn how you can update that model file and yeah, fine-tune your models. Okay.
Hey, is it the same time next week?
Same time, yeah.
Cool. Thanks.
Good stuff. Yeah, you can actually connect to Colab from VS Code. Yeah, so you can do that, or you can also connect to VS Code from Colab if you want to use your local resources. So you can do it both ways, which is maybe confusing. Okay, we're going to do one more thing. Yep, we've got 20 minutes. Basically, we are going to just connect to a bigger model. We're going to connect to Gemini. Like these are the big ones. And this again, we get an API key. We pick a framework to use, and we then ask questions and send questions. Was there a question, or did someone unmute themselves? Oh, good. Oh. Okay, so let's do that. So we're going to be using the Google Gen AI package. Some alternatives to that are, let me think. Like you can write this in curl. You can use it yeah, you can use like basic what are called requests to interface with this, but the Gen AI package kind of makes it a little bit easier. But we'll go and grab a API key from Google AI Studio. So very similar. However, keep in mind these models are based. Let me just copy that link for people. Put it in the chat. Yes, the recordings will go up probably tomorrow. Does that work? Why is that working? Copy link address. Paste. There we go. Okay, so recordings will go up tomorrow. Okay, so all right, we're going to go to AI Studio, and we're going to create an API key. So AI Studio is just like a sort of another level or a way to interact with proprietary models. So Google has their Gemini suite, but if you did this on OpenAI's and ChatGPT's and Anthropic and Claude, they have very similar sort of like interfaces and everything for interacting and getting access to a model. There's a reasonable free tier that you can use. So I'm going to create a new AI API key. Yeah, I'll call it Gemini API key. Sure, create key. And good stuff. Okay, and I create it there. I can see, yeah, actually the one I created in, that's a paid account, but then I've got these other ones as well that are in the free tier. I can just use one of those, one of the free tier ones, and I'll come back to, where's my notes here. And we're going to copy it into here, basically. So I'm going to import Google from Gen AI, and then I'm going to set this client, which connects us to the cloud. So maybe I can make a new notebook, or maybe I can just continue here. So import, what was it? Import Gen AI from Google. Import, from, okay, actually we haven't seen this syntax before. From Google, import Gen AI. So Google is like a massive package. We just want one part of it. So we could do this for NumPy as well. You can say from NumPy, just import mean, or just import standard deviation. But here we're importing the Gen AI sort of sub package. So from Google, import Gen AI, and then client equals Gen AI dot client API underscore key equals, and then paste my API key there. So I'll do that way here, and I'll run that, and hopefully that should work. Good stuff. It looks like it connected. Again, client is just some weird variable type. It's a Gen AI type of client, which connects us to them. Okay. And now the next thing we're going to do is going to grab a data set from Kaggle. So I'm just going to click the copy button, and this will automatically download and unzip some data just into my Google Drive. You can see in my content open. Yeah, okay, so it's just downloaded this NOAA reef bleaching data set. You can read more about that, but we can also explore it. Again, just in the interest of time here, I'm sorry to do this, but I'll do a little bit of copy and pasting. So we can just explore the whole data set. We're going to import pandas, and we're going to actually read the CSV in. So we'll read the CSV in, and we're going to take a subsample of it because it's quite a large data set. You can, if I execute that, you can see it's a data frame just like kind of what we had before. There's a column that says bleaching, which is yes or no. We could turn that into a true or false, make it a Boolean. Tells us which ocean it is, got integers for years, has depth in floats, and then it has these other categorical variables. You can look at the entire data frame. So the data frame looks similar. There's 9,000 rows and 12 columns, and there's a whole bunch more columns as well. But just for the interest of this demo, we've taken a little subset of them. Okay, so that's fun. There's some little, there's a little sort of plotting exploratory data science, data exploration that you can do. So it imports these two packages called Seaborn and Matplotlib, which allow you to plot things basically. So you can set up a figure, and then you can say what type of plot you want. And the cool thing about this is, once you've generated these figures for you can regenerate them 1,000 times. So better than something like, I don't know, using Excel or using Adobe Illustrator or something. You can recreate the figures easily and automatically. But so, there's just a little bit of interest about this reef bleaching cases. So this data set has a whole bunch of reefs that have been sampled. The majority of them, so it's very biased, they haven't been bleached. And then a few samples have been bleached, and there's some distribution about the status, about what depth they are. So the ones that say no, there's sort of like a wider kind of range, but not really that much. So the depth doesn't appear to be too important in terms of reef bleaching, but we could explore some other variables as well. But we'll focus just on we'll focus on the large language model call. So when we send data to a large language model, when you upload, like in Gemini, you have all these options to upload. You know, you can upload PDFs, you can upload CSVs, you can upload Excel files, you can upload all these different data types. And what it usually does, it will convert them to some data type that it actually understands. And a lot of the time, it's just text. So that's the easiest way to deal with it. You need to somehow turn whatever data you have into tokens that the model understands. And the tokens that the model understands is just strings of text. I think that's a very maybe naive and simplistic way to view it, but yeah, if anyone else has strong opinions about that statement, that's sort of what's happening when you pick a data type to upload. It goes, oh yeah, that's an Excel file, cool. I know how to convert that to text. I take this bit, and then I'm going to space it out, and now I can interpret it and relate it to some idea that I understand as a model, as an AI model. And so that's what we can do here. We can convert our little sampled our sampled data frame, df string, into a string. And so this just converts everything into a string, that data frame that we had. And we then can pass that up to the model and say, hey, can you please look at this and help us interpret it and understand it? So it's just a fun little way to kind of interact with the model using this data set. There's probably like more intelligent examples and things that you can do with it. This is sort of one that I had in mind. And then you can build out a prompt to pass to the model. So you say, I have the following experimental data. And then you put that string in that we just created. Please answer the following questions about the data. And then I have a question here. Based on the provided sample, what patterns or commonalities do you notice among the reefs experienced bleaching? Bleaching is yes compared to those that do not bleach. Bleaching equals no. So you can be as strict or lazy with your prompts as usual. But there's my prompt. That's what it looks like. Again, it just turns it into a big text string. I have the following experimental data, and there's the data. Please answer the following question about it. And I'll put that question on. So I just added these strings together. And now my full prompt will look like this, that I send off to the large language model. I have the following experimental data, blah, 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 blah. And then it's got my question there. Okay, cool. So then we do the fun part, I guess. So all that is just sort of data wrangling, getting your data into the right format to send to the model. So I'm going to say response equals client dot models dot generate underscore content. And then we have to give it a model that we want it to use. And we'll pick Gemini dash 2.5 dash flash, but you could use, whatever ones are available within AI Studio. So you can go and explore them, explore all the different models available here. So there's all these different models that you can use for different purposes. Okay, so model Gemini 2.5 flash, and the contents, that's what we're going to pass the model, is the full underscore prompt. And this could be anything. You know, we could pass it other things. There's a whole bunch of other options as well. So this is where we can tweak things. You may have heard of terms like temperature, which control how like wild the model is. We can just use the default values, but using code and using Python, it gives us access to a lot more knobs, I guess, to tweak. Okay, so we run that. We send all that data up. Is Gemma suitable for on-device food nutrition query answering in a PWA? What's a PWA? But I guess the answer is probably Gemma is suitable. Specifically, food.
Progressive web app.
Oh, there you go. Progressive web app. Thank you. The answer is probably yes. So yeah, like Gemma is a very good model, and it has like a good range, so you can pick sort of the right model for the job. And then there's these other variations called like polygemma and medgemma. There's a robot gemma, is what's it called, ER something. So there's all these different gemma flavors for different kind of use cases. Okay, so if I go response, I can see exactly what it sent me. And so the response, this thing is, if you're used to using any web sort of thing where you ping a remote repository or a server, you get a response back, and that's why I called it response. And within that response is all this different data. There's all these sort of things. The thing I guess we're interested in is the answer here. So based on the provided sample, here are the patterns and commonalities noticed. And then among reefs, the experience bleaching. So you can see this is really like, this is a much more high level answer than our Gemma model that we used, our very 270M Gemma model. This is a massive model with Gemini. And it goes on into detail. And we can read like why the model stopped printing tokens. We can get response IDs. You can see how many tokens it used. So our token count, 320, was how many tokens it was made up of. And then it responded with a bunch more. Then it thought for a while, so it used a bunch of tokens, sort of putting its own context together. And again, it will that remember it? I don't think that will remember it by default. There is a way to pass like the, what have we got? So we have this response ID, so we can pass that response ID rather than pasting the whole response like we did earlier. We can pass that sort of back and forth, so it will remember that conversation. Okay, and yeah, you can ask it whatever questions you like as if it was the normal model. But okay, so that's the nuts and bolts of it. We can now connect to a large model in the cloud. You can track your usage. So if where is it? Dashboard usage. And there's certain rate limits in the free tier. It's enough to play around with, and you can sort of change models to avoid the rate limits. You can see what I've been doing and what I've hit and stuff. This is requests per minute and tokens per minute, and then there's the tokens per request per day. And then my peaks that I've used, and then total tokens and so on. So there's but then you can also, if you go to the paid tier, it's like $1 for millions of tokens, so it's pretty good anyway. All right, so yes, we've covered a lot today. To go from 0 to calling large language model APIs is a huge step to do in 2 hours. So thank you everyone who's still on the call for your patience and everything, and for listening. Like, it's fantastic. Thanks for all the good questions that were happening throughout the session. Just recapping, we did all those fundamentals in the first session, which sort of set us up to go into the local models using Gemma and Keras that we're pulling from Kaggle in the second session, and then also looking at how we can interface with the Gemini API for really big models. And keep in mind, where your data is and what data you're working on. If it's public data, like sending it to the API is no problems. But if it's private medical data or something, then local models is the way to go. So I mentioned earlier, there's a bunch of resources for more learning. You can follow these different tutorials and everything. The software carpentry and data carpentry is a great introductory to Python in general. You can go on Kaggle and use the Learn courses there. You can dig down. Reading the documentation is super important, or being able to read documentation is really like a skill almost. And Python documentation, it seems to be laid out in a certain way, so you can dig down to see what a function does and what options there are and what variables to put in. And so we're going to use all these skills in the following sessions as we go through the next few weeks. And obviously, yeah, there's a bunch of different use cases for large language models, but for AI in general in science. And yeah, I'm excited to sort of see what comes every day. There's new things coming out. Okay, so thanks very much, everyone. I'll just see this module at this point. I have no plans for a repeat. I definitely could repeat it if there's demand for it, but it will be recorded and put up on YouTube. And yeah, I don't think it'll share with everyone, but it will go up on the GDG page and our YouTube site, sort of in the next day or so. And when and just on VS Code, the final session is on anti-gravity, which basically is VS Code with a so it's a way to use Python not on a notebook, but it's you can use sort of Python in a local development environment. And we'll be talking about anti-gravity, which is Google's VS Code flavored editor. You won't get the, I don't think it will come in the, what is it, YouTube, GDG Science, this one. We'll be covering MCPs. I'm planning on it. I have to update the notes to talk about MCPs a little bit. Yes, because I just found some fun at MCPs the other day. My copy and paste isn't working, but, oops. Okay, let's try again. Copy, paste. No, why is it not working? Copy, paste. Yeah. Okay, sorry, my copy and paste isn't working. But if you search for GDG and .com and GDG Science, you should find it. Okay, thanks very much, everyone. Have a fabulous week.